Welcome back, guys. Have another method of joints example. So let's begin as we always do by identifying the support reactions. So for AY, it's going to be a normal reaction, isn't it? Because it's a roller support. And then CY and CX because it's a pin support. Okay. And this time let's begin the problem by obtaining the values of these support reactions first. Because if we were to look at joint D first, we have three unknowns. That's the DA, DB, and DC members, right? So I think it's easier if we just find the support reactions first and then work our way up the truss. Okay, so sum of the moments about C, going to define positive as counterclockwise. So what moments do we have about C? Well, there's going to be this moment here, isn't there? And this here is 4 meters, the perpendicular distance. So, and is that going to turn clockwise or anti-clockwise? Well, it's going to want to turn like that, isn't it? And that is anti-clockwise, so that's going to be a positive moment. So positive 450 times by perpendicular distance, 4 meters, plus our other moment is going to come from AY, isn't it? And it's going to want to turn like that from joint C. So this one is going to go clockwise, isn't it? That's going to be a negative moment. Distance, that's just going to be 8 meters equals 0. So then we have a y equals 450 times by 4 divided by 8. And that is 225 kilonewtons. Great. Now let's do our sum of the forces in the y direction equals 0. So which forces do we have in the y, guys? Well, we're going to have a y that we just calculated, 225. And the only other vertical force is going to be cy, isn't it? And then we've drawn that correctly in the negative direction. So cy equals 225 kilonewtons. Easy. And in the same way, let's do sum of the forces in the x direction equals 0. So here we have the 450 kilonewtons in the negative x direction. And then we're going to have Cx in the positive x direction. So very simple, Cx will equal to 450 kilonewtons. Easy. Okay. Now let's proceed by looking at joint A. And before we look at joint A, we need to know what this angle here is, right? So how are we going to get that angle? Very simple trigonometry. Theta equals arctan opposite, 4 meters, adjacent, 4 meters. Arctan of 1, guys, 45 degrees. Easy one. So this is also going to be 45 degrees, isn't it? Okay, so let's draw the free body diagram for joint A. So we have a member going like that, member going like that, and our AY force going up like that. We calculated that as 225 kilonewtons. That's AD, that's AB, and that angle is 45 degrees. Okay, so let's start by summing the forces in the y direction. So we have our positive AY force, 225, and I'm going to assume negative, and it can only come from the vertical component of AD, right? And what's that going to be? What's our vertical component? It's going to be this value here, right? And that's going to be the sine. So the opposite, which is this y value here that we want of AD over the hypotenuse, which is AD itself. So that's going to be AD sine 45 equals 0. There's no other vertical components of any members in this free body diagram. So we can just solve for AD. AD is going to be 225 divided by sine 45. And that equals to 318.2 kilonewtons. Now, is this AD going to be in tension or compression? Well, because it's going downwards, it's going to act into the joint at A, isn't it? And what do we know about compressive joints acting towards the member? It's going to be in compression. Compression. So that leaves us with AB as our last unknown. Sum of the forces in the X equals 0 equals, so it's going to be the X component of AD, isn't it? So that's going to be, I'm assuming, in the negative direction, because if that's, this member here is going like that, it's going to have this X component that we need to calculate. So that's going to be negative 318.2 cos 45 plus AB. So that just leaves us with AB equals 318.2 cos 45, and that comes to 225 kilonewtons. And so this member, so AB, I'll just redraw it. That's AB. It's going in the positive direction, isn't it? So that's going to be in tension. So now we have the forces for AD and AB. Let's quickly label them. So AD was 318.2 kilonewtons in compression, and AB was 225 kilonewtons in tension. Great. Now let's look at joint B. This is going to be super easy, guys. Joint B is like that. So we know that CA, or sorry, BA, we know that BA is in tension. We just calculated it. 225. So this one here, that's going to be B. Is that going to be BC? Yes, this member here is going to be BC. I'm going to draw it like that, BC. And this member here, what's that going to be? The vertical member. That's BD, isn't it? Okay. Sum of the forces in the X equals 0 equals negative 225 plus BC. BC is the only other horizontal component. So BC is just going to equal to 225 kilonewtons. Now, do we have any vertical components, guys? We do. We have BD, but we don't have any, I guess it doesn't have any magnitude. So it's just going to be BD equals 0. How easy is that? BD, 0 kilonewtons, and we call that a zero force member. So that's a new one. But otherwise, we've got everything that we need. So BC, it's acting away from the joint B, so that we know is going to be in tension. Just going to put 0 force member for that one. And then BC is going to be 225 kilonewtons, also in tension. So the last member that we need to calculate is this one here, right? DC or CD. Let's draw that last one. So this one is joint C. And we know this one here is acting away from the joint at C. That is, we just calculated as 225. Then we have our support reactions. So Cx we calculated was what? 450 from memory? Cx 450. Yep. And then Cy as 225. So 450 and 225. Okay. Sum of the forces in the y equals 0. So this member here we're going to call CD. We just need to know the y component of this CD, don't we? Just like everything else. So we don't need to worry about these two, which are only x component forces. So we have a negative 225, that's this value here, plus, so I'm going to assume that this is going in the positive direction by process of elimination. This component here is just going to be the sine of this angle. So CD sine 45 equals 0. So then we have CD equals 225 divided by sine 45. What's that going to equal, guys? 318.2 kilonewtons. CD acting away from the member at C, that's going to be in tension. And we are done.